Hi everybody and welcome. Today's video we're going to be focusing on solving for unknown quantities in special right triangles. So actually this is more or less just an application of the Pythagorean theorem, but it's a shortcut for two specific examples of triangles. And these triangles are used all the time, which is why we're going to take an entire video here just to look at these two specific triangles with these specific angles, and it's going to make you an expert on solving for unknowns in those without having to do the Pythagorean theorem every single time. So a 45, 45, 90 triangle is just basically saying you have two angles that are 45 degrees, and then of course the other angle, it's a right triangle, is 90 degrees. And these triangles have a very specific relationship. The legs, these are the shorter sides, are in a 1-to-1 to the root of 2 ratio to the longest side, or the hypotenuse. So a proof of this is if we set this up in that same ratio of a 1-to-1 to root 2, we can label this as A, B, and then of course the longest side hypotenuse is C. So if we do A squared plus B squared equals C squared, and let's color code this, that way we know where everything's coming from. There's A, there's B, there's C. Well, we can go ahead and replace these terms. So we have x squared plus x squared again equals c squared. Well, c squared in this case is all of x times the root 2 squared. So if we evaluate this, root 2 times root 2 is just 2 by definition. 2 root 2's, the roots cancel, and it's just a 2. You can punch that into your calculator. Even with those decimals, you'll still get an answer of 2. X to the second power is just x squared, so we're left with x squared plus x squared equals 2x squared. Well, 1x squared plus another x squared just equals 2x squared. So that's a proof of how this works. And if you want to go back, you can do the Pythagorean theorem for any values that we're going to do next, and it'll still work for you. But today we're going to show you a shortcut using this proportion. So we know when we're solving these that we're going to be in that constant proportion of a leg is 1, and then the long side is root 2. So we know that this leg here is the 1 in our proportion. Same thing here. And we know that, we'll do this in red, the long side is equal to the root of 2. So just like we were doing before break, we're going to set this up in a proportion. So we're going to keep our ratios constant. So if we have a 1 and a 1, we're going to be drawing the things that are across from that. So across from this one is 4 root 3. And then across from the second one is just x. And then we can go through, we can cross multiply, divide, and solve for our answer. So let's do that. So we're left with x equals 1 times 4 root 3, or x just equals 4 times the root of 3. We can do the same thing again now, set up a second proportion. And again, this is just for example 1, so I'll kind of draw a line here to make sure that we don't get those messed up. All right, and let's do this. We'll do this in highlighter this time. Y is across from root 2, so we can draw root 2, and we know that y is across from it. And then secondly, we know that 1 is across from 4 root 3. And I should draw that in highlighter there. So we can draw this here. We know that 1, and then we have 4 root 3. So just like we did before, time to cross multiply. We'll get y equals 4 times root 3 times root 2, or 4 times root 6. And that's it. So today your job is to really focus on setting up proportions like we're doing here and knowing what's across from each of those terms. So on the actual triangle itself, that's going to be one side of the proportion, and then those terms and that ratio that we described above, well, that's going to be the other side of that proportion. So in your book widget form here, you're going to have to do example 2 and example 3, and you're going to want to set it up the same way. This is your one side, your root 2 side. Your one side, your root 2 side. And if you do that in the proportions, you can avoid using the Pythagorean theorem, save yourself a whole lot of time, and work fluently with these types of triangles. All right, let's go on to a second example. This is the other one that we need to know for today. This is a 30, 60, 90 triangle. So one side is worth, the short side is worth 1, the longer side is worth root 3, and then the hypotenuse, or the overall longest side across from that 90-degree angle, is worth 2. But let's just check this real quick with what we have here. So we have A, we have B, and we have C. So A is x squared, plus B is x times the root 3, all squared, and then C is 2x again, all squared. So we have x squared here. Root 3 times root 3 is just 3. Again, x squared is x squared. And then we have 4x squared here. Well, is this true? 1 plus 3 does equal 4x squared. So again, another proof to know that this is how this works. So secondly, just like we did before, we want to set this up with our shortest side is our 1, our longest side is our 2, and then our middle side, we'll call it, is actually root 3. So a little bit out of order. You think it would be 1, 2, root 3, but 2 is actually greater than the root of 3. If you punch that into your calculator, you can see those decimals there. So we'll have the green side of our proportion, maybe we can call it, and then we can have the blue side as the actual values from the triangle. So we'll call it our blue side over here. So let's get this set up. So on the green side, we can use 1 and 2, and then on the blue side, directly across from 1, we have 2 root 3, and directly across from 2, we have x. So now we go ahead just like we were doing cross multiply. So x is 4 root 3. Now let's set this up again with our green side and our blue side. Our green side once more, we want to use the terms that we have here. So we have 1, and now we have to use root 3. And then on the blue side, across from 1, we have 2 root 3. And then across from the root of 3, this time we actually have y. So going through and solving this, we can now see that y equals 2 times root 3, which is just 3, or y equals 6. So all things that we can check and verify using, again, the Pythagorean theorem, but this is a shortcut. Save yourself a whole lot of calculation. And again, remember the way to do this is just set it up correctly. Across from the 1, the x is 1. This term is our root 3 side. That's our 2 side. Again, 1, root 3 is our longer leg, and our hypotenuse, or the longest side overall, is 2. So have your proportions, know the actual values of the triangles, and then the values from this proportion here. And if you do that, you'll be really successful solving for these. And again, we'll save yourself quite a bit of time using the Pythagorean theorem. As always, questions, we want to answer them. We're here to help. Feel free to send a message, send an email, book an appointment, any of those things to go over this skill. But as always, everybody, thank you so much for tuning in, and I'll see you.